I want to start by asking how many of you recognize that code? One hand up, Mark Siegman. Nobody else? It's POP2. And I'll come back to what it means later on. But my very early on in life, and this was well before LFCS started, I worked in Edinburgh. And it was a wonderful time in many times. You know, there was sort of a huge amount of intellectual ferment, but there was also rather a lot of political ferment. And I was, in some sense, in the wrong side. I was attached to what was then the theoretical psychology unit, and then became the School of Epistemics, and then what did it become, Mark? I can't remember, but the Center of Cognitive Science, and it became something. But there was this a clash of titans, and I was unfortunately caught in the middle, so I didn't have exactly the sort of interactions I would like to have had with the rest of people who were to ultimately form LFCS. But I did, on some sort of low level, have a lot to do with it. And I spent an awful lot of my time writing programs. And I spent them in this room. Actually, when I came back to Edinburgh, I was asked to teach a course with 100 database students in this room. I think I'm right. This is the room in Forest Hill where there was a Ferranti computer, 24-bit machine, and you can still see the raisable floor there and everything else. And when I got a bit more advanced, I computed from home. I had a teletype and a modem, and I got about 100 bits per second over that modem. And when I came back to Scotland, I was still getting that speed up in the Highlands. And so nothing much changes. But I remember I spent, for the life of me, I wrote lots of programs, and I cannot remember what they did, but the fact that I was writing them was very important. I also, but just by way of reminiscences, remember, and talking about Freddie, that was actually a considerable triumph, not only of programming, but of mechanical engineering. And I spent a lot of time in Steve's workshop with Robin Poppleston. We both had boats at that time, and we both used the workshop to build bits of our boat, our respective boats. And I remember Pop had brought in this very rusty old engine, which was out at the bottom of his boat, and it wouldn't start. And so he took it apart and put it back together again and polished it up. And nobody expected it to start, but he pulled the starter and it did start. But unfortunately, it had a centrifugal clutch on it, and the clutch sort of zoomed off and sort of smacked. Well, you can imagine. Anyway, so much. Anyway, so that was all a long time ago. But the important thing was I actually did a lot of programming in POP2. And then I left, and actually some of my best research was done there, but it was on combinatorial problems, but not really associated with LFCS. So I went to pry the gold off the sidewalks in America, and I was told that the sort of work I'd been doing on mathematical phylogeny was not particularly wealth generating, and I should, why didn't I think about databases? That was an up-and-coming topic. And at that time, relational databases had been invented, but they were regarded as a theoretical nicety. And what we had, and what still exists in many senses, although not by this name, it was a model called Codicil, where you had, they organized data like this. You had, think of departments which have employees in them. The Codicil construct was a thing called a set. And a set had an owner, which is this department, and its members. So the set had a member, but it had just one owner and had a bunch of members. And if you look at that for a moment, it's doing nothing more than providing you with an extensionally defined function from employees to departments, right? The sets were non-overlapping, they were disjoint. And so we were, and query languages were being developed. SQL had been developed in some sense. But there was nothing for Codicil, and people wanted stuff for Codicil. And so an embarrassing long time ago, when LaTeX had not been invented, we said, well, okay, let's just represent the database as a set of extensionally defined functions. So you have some niladic functions which generate the sets of employees and departments, and then some other functions which map between these sets. And that was a nice model, and actually two people, we and another group of people invented. But then the fact that I'd been programming in POP2 and had developed a love for combinatorial programming came into play. Why don't we just program by composing these functions and doing what we have to do? And I remember this very well, because let me tell you what I think this does. Please correct me if I'm wrong. I discovered the joys of lazy evaluation. You could write down workflows and compose functions, and then press a button. And what this does was, it takes the output from your program, turns it into a list, applies the erase function to each member of the list, so it throws away your output. Now, I think there are two messages you can take from that. One is, actually, this is the sort of run command. And the other message you might take is, well, why can I not remember what my programs did? Well, because they never produced any output. But the message from POP2 had got through, and this, I should say, was many years before. Does this button work? Yes. Moji had spoken the word, and Wadler had not preached it either. I'm talking about monads, but you'll see, and we didn't know what we were doing. We said, well, to get this stuff off the ground, you need composition. This thing is going. You need what we'd now call a map. This restriction or a filter is actually not, and we knew it at the time, was not actually fundamental. You needed products, and these were all the higher order functions we need, and we needed these other functions, sort of concatenate or a union operation, and then we needed a /conc, which flattens an arbitrary a set of sets or a list of lists or whatever into a list, and we even needed tensorial strength. All this, and we didn't know what we were doing, so it fell by the wayside. But it did actually get used, and it was quite an important part of my career. It got me off the ground in working in databases, and it was thanks very much to what I'd learned early on with functional programming. And, oh yes, I'll just show you. This was it's going to be important. This was a typical function that you wrote down, just reverse product composition. This we are particularly proud of because this is the thing which was then called bill of materials processing. When you have a parts hierarchy, which they have in industry, and you want to add the total cost of making a part, you have to compute a sum over the hierarchy, and that was done in just one line. We're very proud of that, and actually it was actually quite useful to people who were trying to write complicated query languages. So many years went by, and I worked on databases for a time, and I would say quite a lot of the influence emanating from Edinburgh was very important to what happened. The first thing that worried me, although it was not particularly an LFCS problem, was the practical problem that when you write code with databases, you have to use two languages. You use a query language, and you use a programming language. The query language talks to the programming languages. It talks in an extremely awkward way. The database gets reduced to a bit stream, and the programming language has to gobble up the bit stream. And the programming language pushes sort of English text back down into the database system, and that's the source. There should have been, so that has been going on all through my career, trying to do this. Then some notion of domain theory and partial information databases. ML and record polymorphism, I'm going to show off. I'm rather proud of the fact that when I learnt ML, I thought, and I was teaching introductory computer science at the time at the University of Pennsylvania, and they have a very nice attitude to teaching. I said, well, what should I teach in introductory computer science? What language should I teach? They said, teach them to think, they said. I said, well, yeah, but what language? And, well, the AI people said it doesn't really matter so long as it's Lisp. And algorithms people said, well, it doesn't really matter so long as it's C. and I actually taught ML as the first course for several years. I think I was the first person to teach ML as an undergraduate, as a first language, actually. I'm trying to remember, it was not long after Luca's compiler came out, because I think the first view that it was Luca's compiler. And then, of course, the really nice thing happened, that when 10 years later, we revisited SQL, and thanks to the work that Phil had done in understanding the relationship between monads and comprehensions, the whole thing fitted together into a sort of beautiful whole, where structural recursion, relational algebra, nested relational algebra, all fitted together in a very, very nice way. And God knows what would have happened if we'd realized that 10 years earlier, but we didn't. But that was one of the nicest sort of parts of my career. And then other things like partially static type systems for semi-structured data. So, throughout my career at Penn, although I was doing databasey stuff, I was working on this. Now, actually, quite recently, oh, damn, this has gone, the formatting is here. I was visiting, there's a local telecoms company that I was talking to. I said, oh, we've got this wonderful new database system. Forget relational databases, this is the one that we're using, and it's got all these wonderful properties. And I looked at it, and it's no secret that RelQuery rethink query is modeled on Haskell, blah, 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 blah. And here is, I'm sorry, this is not formatted, but here is a query in their query language. Filter, map, blah, 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 and then at the end, run. Sorry, that run should be up there. That run is chain.fntolist erase.applist. Okay, so I'm going to fast forward now. That was fast forward in the past. I'm just going to talk a little about what being here has meant recently. Some sort of random thoughts on the difference between the research environment in the UK and the US. I mean, one could go on about the UK scientific bureaucracy, but that would take far too long, and I've only got through 15 minutes, so I'll concentrate on some of the good things instead. And the US is much more directed and less forgiving, and there was nothing, I never experienced anything like the intellectual ferment that we had. And even coming back here, I was exposed to much more interdisciplinary research. But I should say that interdisciplinary research can be a huge time waster. That is to say, you collaborate with biologists on some, and basically, if you're a database person, they want you to write their SQL schemas or, do that. But if you persist, just occasionally very interesting nuggets come out of it. They ask you questions and say, I hadn't thought about that. So I'm just going to talk about one such question that's come up relatively recently. I don't know whether it's particularly fundamental, but it's a lot of fun. And that's what I'm going to talk about. So when I came here, a man called Tony Harmer, who used to work just across there, in fact, had this curated database, which was a database they publish on the web. It's a relational database, and it's really quite important. It's a sort of first port of call if you're interested in drug interactions, how drugs affect what happens across cell membranes. Now, I'm sorry, the pictures here are terrible, but this is just to show you that it's a sort of interesting mixture of text and of tables. Oh, I just want to go back and say something. I meant to say it, but I moved into LFCS. Why did I come back to LFCS? Well, I have two theories. One is, I actually remember saying, oh, it's full of all the bright people, so that's where I'd like to be. But it actually Phil, so I'm going to tell a story at Mike's expense here. When it came to moving into this building, and Mike had this theory about the structure of informatics, which was that everything was founded on data. So data had to go at the bottom of the building. You get it? Database, basement. and then it went up and up and up until right at the top you got informatics. And I said, no, the group's in LFCS, so we go at the top too. So one of the incidental benefits of being a member. Anyway, let me get back to the topic.
You realize this is the only building whose foundations are at the top floor.
Yes, good. Sorry, just... So Tony Harwood just came from us, and he was constantly pestering me, how are we going to raise money to fund the database? And he said, by the way, I'm trying to get people to cite my database, because it's actually been built by a large number of academics, hundreds of academics across the world who contributed material to it. And when they click on a page, or when they do a query against it, there should be a citation that goes with that. That's how they get kudos. And, it was one of these things I thought about, and turned out to be a sort of semi-interesting problem. And I wrote a little paper about it 5 years ago or something like that, and didn't pay much attention to it, actually about 6 years ago. But then suddenly, recently, citation has become very big business. But all these important organizations saying data citations should be accorded the same importance as scholarly record, and blah, blah, blah. Oxford University, describe your data to enable other researchers to cite them. Notice that all these people, you can tell they're librarians because they use data in the plural rather than the singular, which we all know it's a mass noun and not a count noun. But anyway, so, but everybody is yelling, including the EPSRC, about citing data. And it's a real problem. What is a conventional citation? Well, it's just a collection of snippets of information about your publication. How am I doing for time, by the way?
10 minutes.
10 minutes, so I'll be finished in 5, so that's fine, good. It's not exactly provenance, which is something else. These citations are self-contained, they're immutable, they're not something that, they travel independently of the publication in some sense. And they're needed for a variety of reasons, for understanding kudos, currency, recognition, authority, and so on. And they're especially important in these curated databases, like Tony Harmer's database, for precisely the reasons we've mentioned, for the recognition for prescribing authorship. But the problem is that the authorship varies. You go through the database, and depending on which part of the database is, the citation varies. And the database changes over time, too. It's entirely non-trivial to do this. And so the problem is, you have a database which has been contributed by lots of people. I just go in there and throw an SQL query and what citation am I supposed to use for this? And there are a number of ways of getting these. So all these are essentially queries for getting stuff in the database. So we can't expect every bit of the database to have an entry in DBLP. Because there'll just be a huge number. I mean, a convention system in which would be infinite numbers. But that's not possible. But it gets worse. Imagine you're a biologist and you've got to query out. Well, this is what one of these organizations, this is the XML schema for citing a database. This is the format to which your citation, it's 400 lines of XML schema, quite impenetrable. If you clicked on a button to generate some code, to generate a web page on the fly, well, this is an example of a 700-line machine-generated SQL component of some API. How on earth, look, if I want to cite one of Mike's papers, for example, if I can't find the citation, actually, even if I can't find the BibTeX entry, I'm quite likely to forget about it and cite somebody else's, right? I'm lazy. How on earth is some poor biologist expected to understand that lot and this lot and generate a citation? But that's the situation we're in the middle at the moment. And so the point is that unless we couple the process of generating a citation, this advocacy of of citation is pointless. And so the main problem is, given a database D and a query queue, generate an appropriate citation. Simple as that. How can we do that? What's the strategy? Well, if you go to anybody who publishes a database in this way, you can say, you can pose it that way and say they have a first idea. Analyzing even an SQL query is going to be intractable and probably undecidable problem for some things. But what they can do is say, oh, well, the bit that looks like this should have a citation like this. So maybe they've got a tree-like deconvolution, they say like this, or maybe they have a project select query and say the citations should look like this, and citations. So they can actually give you citations for chunks of the database. So, and these things are called in general terms views, because they are extracts from database. They're databases that you've extracted. The views don't even have to be in the same data model as the other things. So you have a bunch of views. And then the question is, if I give you a query, can I factor it through one of these views? If it is, then that view determines the citation. Now, it's interesting because that's actually a very well worked upon and current database problem. Is rewriting query using views. It actually came up in the context of database optimization, but that's where it's happening now. That's a new use for it. And stated formally, it says for any database that conforms the schema, can we write a query that can be written through a QI through the can we compose a view, another query with a view to get the answer? Notice that this has a universal quantification. So actually, there's something weird going on here. I said the citation doesn't depend on the database, which is weird, isn't it? Actually, it does, because when we define these views, there are actually a large number of them. There might be one view for each author. And in fact, there are, in many databases, there are several things. So these are actually parameterized views, and this makes the problem a bit more interesting. So although the standard technology of rewriting queries through views is understood, this idea of a parameterized view adds a new twist to the problem. I don't think an insuperable twist, but an interesting twist. Anyway, the upshot is that, so here are examples for the sort of views in a hierarchical decomposition of Tony Harmer's database. At the higher level, you have, I don't know if you can read the authors there, they refer to them as collaborators. Further down, they have different names. And each of these different colors has a different kind of citation. And they can all be expressed. Actually, there's a sort of nice, simple pattern matching language based on XPath that you can use in this case to match queries to citations. Of course, I should say that this doesn't always work. You might find there's no views, there might be many views. The views are in a hierarchy. Do you use those two or that one? There are unsolved problems, but at least it gives you a handle on the problem. It's not sort of a total mess anymore. You can go in and narrow it down. And there you see they've actually, or you can't see it because it's all there, but they've actually implemented it more or less. It's running there. And oddly enough, it actually works for other kinds of data. Here the views are from the database is actually a bunch of files of data taken from Landsats that are orbiting the Earth. And the views are interesting. They are the views are the spatiotemporal, they show up somewhere in here, the spatiotemporal bounding boxes these things here. Okay, the space and time. They also form a hierarchy, and that is what they want out of it. Actually, there's also the author, but that's a relatively simple thing to extract. So the nice thing is that the same idea works in a very, very different setting. And the Reader's Digest version of this talk is going to appear in CACM in a few months' time. So I thought I would put that in just by way of sort of light relief, because it's a fun problem, but it has some interesting database aspects. I wanted to say that actually, thank you to LFCS, not only for forming my first part of my career, but also enabling me in my dotage to go off and do nutty things like study database citations and other things as well, which Mike well knows about. It's really nice. Thanks a lot. I owe, indirectly, although a huge amount to both LFCS and to informatics. Thanks.